this video, what we're going to do is we are actually going to go through the practice problems on your in-class practice worksheet. So here is the first problem. In a certain country, length is measured in piddles and daddles. One piddle is defined as exactly 3.33 daddles. How many piddles are in 7.00 daddles? So, I start here with my train track. This is the value that I start with. And I'm going to abbreviate daddles as DAD. Now, my conversion factor is actually found in this sentence right here. Now, if I look here, down below in my problem, I know I'm going to want to cancel out my daddles. So my daddle unit is going to go on the bottom, and the piddle value is going to be on top. If I read the sentence, one piddle is 3.33 daddles. So my daddles unit will cancel. 7 times 1 is 7, divided by 3.33, and I get 2.10 piddles as my answer. All right, let's take a look at number 2. Number 2 is actually a multi-step problem. Okay, how many kilograms are equal to 400 milligrams? So, I have 400 milligrams here. If you look at your conversion sheet, I don't have a conversion that relates kilograms directly to milligrams, but I have a conversion factor that involves milligrams. 1 gram is equal to 1,000 milligrams, and I have one involving kilograms. 1 kilogram is equal to 1,000 grams. So this is kind of how I'll work it. I'll go from milligrams to grams, and then from grams to kilograms. So starting with milligrams, I know that milligrams has to be on the bottom, and grams is going to be on the top. 1 gram is 1,000 milligrams. So my milligrams unit will now cancel. So my new unit that is left is grams, but that is not the unit that I want. So I'm going to use the second conversion factor that uses grams to kilograms. In this case, 1 kilogram is 1,000 grams. Now my grams unit will cancel, and I am left with my unit of kilograms. So across the top, 400 times 1 times 1 is 400, and 1,000 times 1,000 is 1,000,000. When I do that math, and I actually divide it on my calculator, I get 0.0004 kilograms as my answer. If you want to double check that answer, all you need to do is use your metric steps. You will see that you actually jump the decimal place 6 times. We're actually going to skip over number 3 and come back to it here in a second. So we're going to jump over then to number 4. How many seconds are there in 2 years? So I'm starting with years and I'm going to seconds. Now most of these time conversions you should know. They're pretty common sense. So if I start with 2 years, okay, a year is the same as 365 days. So my years will cancel. And a day has 24 hours in it. And an hour has 60 minutes in it. And a minute has 60 seconds. These are all on your conversion sheet. So then all I need to do is multiply across the top. 2 times 365 times 24 times 60 times 60. And if I look at the bottom, I have 1 times 1 times 1 times 1. So we know that that is 1. So when I do that multiplication on the top, I get 63,072,000 seconds. And I am done. Question 5. We are changing feet into meters. Okay. Now, this is one where, because I'm going from feet into meters, I need another conversion factor. And the conversion factor we are going to use is 1 inch equals 2.54 centimeters. Now, I'm given a unit starting in feet, so I have 11,647 feet. But my conversion factor doesn't involve feet. But if I look here, I know I can change feet into inches. 1 foot is 12 inches. So now, with this calculation, I'm in inches. Now I can use my conversion factor. 1 inch is 2.54 centimeters. And my inches will cancel. Now I'm in the unit of centimeters. I want meters though, not centimeters. But centimeters and meters, if you look on what you need to memorize, is actually on there. 100 centimeters is 1 meter. And so my centimeters will cancel. So now I'm in the unit of meters. So what I would do is I would take 11,647 times 12 times 2.54 times 1, and then I divide that by 1 times 1 times 100. So I get 355,000.6 divided by 100, and that becomes 3,550.0, oh, I'm sorry, that's a 56. 0.056 meters. And now I'm done. Let's go back and get number 3. Now that you've kind of gotten the hang of it, 3 is probably the most complicated one you will ever see in this class. They can get more complex and more complicated, but we won't go there for this class. If a bee flies at an average speed of 3.4 meters per second, what is its average speed in miles per hour? So in this one, I'm actually going to change 2 units in one single calculation. I'm going to take meters into miles and seconds into hours. Now, there's one conversion factor that I need to give you, and the one I'm going to give you is this. 0.6 miles equals 1 kilometer. Now, the rest of the conversion factors are on that sheet that you will need to memorize. So let's actually set it up. 3.4, and we only put the unit of meters here because if I look at that speed, what it is saying is I travel 3.4 meters in 1 second, and that actually goes on the bottom. If I don't set it up this way, then I can't do my conversions correctly. Now, I'm trying to take meters into miles, but if you look at my conversion factor, it doesn't involve meters, it involves kilometers. Well, that's not a problem because we know, looking at our sheet, that 1,000 meters is 1 kilometer. Now I can change kilometers into miles. So on top now, the unit that I have left up on top is miles, and that's the unit I want. The second thing I need to do now is change seconds into hours, and I can do that on the same railroad track. So if I want to take seconds into hours, the first thing I want to do is convert it to minutes. So 60 seconds is 1 minute. Seconds will cancel. And then 60 minutes to 1 hour. So if you look at what I have left, I have miles over hours, which is what I want right here. So I'm going to multiply across the top and multiply across the bottom. Okay, when I do that, I get 7,344 divided by 1,000, which gives me 7.344 miles per hour. And I am done. Again, you have a homework worksheet that has problems that help with this. In addition, you also got a extra practice worksheet that should also help you with this. So now you should be ready to tackle pretty much any factor label method practice problem that you would get.